Hello Year 5 and welcome to your next science lesson. So I'm going to really test your brains today because I know that this was a very difficult task to get our head around last week, but some of you got this absolutely spot on. So no cheating and going back and looking through your books. Okay, I'll know. Okay, so what I want you to do is you've got the sheet in front of you. Can you identify the names of our different phases of the moon? Okay, so pause the video, set yourself a 5-minute timer and see if you can work out which one is which. And I suggest that you start from the top one, which is the beginning of our phases. Okay, so pause the video and have a go. Okay, let's see if your answers match my magic answer. So the first one obviously is our new moon. Okay, this is when it's directly between the Earth and the Sun. And obviously because it's directly behind, we can't see any of the moon. We just see the shadow. And then as we start to move around, we start to see a teeny tiny bit of the moon. Okay, so we know when it's getting bigger, it's a waning moon. And we know because it's that shape, that banana shape, we call it a crescent. So we've got waning crescent. And then here we get to our half a moon. But this is almost when we get to a quarter of our cycle. So this is the last quarter of our moon. Okay, so we're almost going backwards anti-clockwise. And then we know it's getting bigger. So this is when it becomes a waning gibbous. Okay, so this is now when we have a bigger part of our moon. And clearly, we know this one's going to be our full moon. Now, once we have our full moon, okay, obviously it's now going to start getting smaller. Okay, so we have then a waxing gibbous. We know that waxing is obviously when it gets bigger. Obviously, we're going backwards from this now. We then have our first quarter and we have our waxing crescent. Okay. Now, we know normally that when we do the moon cycle, it goes anti-clockwise. So we know that when we have no moon, although these look like they're the same sizes, we actually go in this direction. So obviously the moon is getting bigger, and we know that waxing crescent meant that it was a moon that was getting bigger. And obviously we have our starting point, our first quarter, our half point and our last quarter before we then have no moon at all. So well done if you got those correct and you remembered where they were, because that was quite difficult today. So today we're going to look at discovering how theories about our solar system have changed. So by the end of the lesson, you need to be able to identify, well, what is a solar system? Then we're going to have a look at understanding the history of our solar system. We're going to look at some different scientists and their theories that they had about our solar system. Then you're going to see if you can tell the difference between a geocentric and heliocentric models, okay? So this is where our theorists have different ideas of how our planets were set up in our solar system. So don't worry about that for now. We will be going over that in our lesson. And then your challenge at the end is to try and correctly match the right facts to the models that we look at for our solar system. So make sure you're paying attention, okay, because you're going to need to know all of these names. So my first question to you is, can you explain what a solar system is? So I want you to pause the video, just give yourself 2 minutes to write a sentence down, to write a definition of what a solar system is. And I've got some words here on the screen for you to have a look at that might help you phrase your definition. So just pause the video and give yourself 2 minutes. Can you write down a definition for what our solar system is? Okay, so the solar system is a group of objects which orbit the sun. Okay, and we know that those objects are obviously our planets. And we know when we orbit is when we move or travel around. Now, the Latin name for the sun is Sol. And for any of you that remember your Romans topics from year 4, Sol was also the Roman name of the Roman god of the sun. Okay, so the word solar, okay, has the beginning of sol at the beginning of it, means to be related or determined by the sun. Okay, therefore our system is powered and controlled by the sun. So the solar powered objects are powered by sunlight. So that is the center focus of our solar system, hence the Sol, which means sun, and it's at the center of our solar system. Now, there have been many theories about how our solar system was constructed, so which planets were where, how they moved around each other, or even if they did move, and what order they appear in their distance from other planets and objects in space. So over the thousands of years, many great astronomers have observed the night sky, and we know looking from the Mayans, they were very good at mapping out the stars, and obviously that's where it started. And theorists came up with their own ideas about how it works. So we're going to have a look at those different theorists and see how that's changed over time. So we're going to go back to ancient Greece. Okay, so we have astronomers in ancient Greece, such as Ptolemy, began making theories about what they had observed. So he studied the night sky and watched how it changed every night and how things moved into different positions. And sometimes there were brighter spots of light and they'd move across the sky. And he noticed that those movements must mean that they are moving in a direction. And that's when they called these wanderers, so obviously they were wandering off on their own little journey, that's where the name planet came from. So he named them as planets. Now the ancient Greeks identified these wandering things as planets, and we've got Mercury, Venus, Mars, Jupiter and Saturn. Now, you might have ever heard of a mnemonic. Now, the mnemonic that I remember for the order of them is many vile earthlings munch jam sandwiches under newspapers. So each letter of the beginning of those words remind me of the beginning letters of the planets in the order. So many vile earthlings would be Mars, Venus, Earth. Munched jam sandwiches would be Mercury, Jupiter, Saturn. Under newspapers would have been Uranus and Neptune. And then it would have been Pluto under newspaper piles, but Pluto got kicked off. Bye-bye, Pluto. So these planets at that point in time, okay, and nowadays if we look up the sky, they're visible for us to be able to see. Now, the ancient Greeks didn't know that they were planets like we do now, okay, but they knew they were different because they moved, so their positions in the sky changed every night. Now, originally they were given descriptive names about how they appeared. So you might have had the light-bearing one, okay, so we've then got the fiery one, which is obviously known as Mars. And that was it. That was before they were then named after Greek gods. Okay, so the Greek philosopher Aristotle, which you'll look at in science potentially next year, then names them after Greek gods. We've got Jupiter, Mars, and Venus. Okay, now they were translated to the equivalent Roman gods, and obviously those are the names that we know today. So we've kept those names, but we've translated them to an English language, but we've still linked them to the names of the gods. So that's where all the names of our planets came from. Now, theories turned to figuring out what the solar system might look like and how it all moves, because they clearly identified that some of these planets are moving and they want to know how and they want to know why. So, to start off with, it was considered that our solar system was geocentric. Now, have a think where you might have learnt the word geo from. I mean, we have geography lessons, and that's the study of the Earth. So, geo means Earth. So what do you then think that geocentric means? Think about the word centric and centre. Earth centre, geocentric. What do you think that means in relation to our solar system? Okay, so geocentric means to have Earth at the centre. So you've got geo and centric, so centre, means that they believed that Earth was right in the middle. And they developed this theory that composed around all the different circles of the planets, the sun and the moon, and how actually they all followed and orbited the Earth right in the middle. So this is what the model used to look like. Okay, so you've got the basic model, this is the geocentric. Remember, geo, Earth, centric, middle. So Earth is in the middle of our solar system. Now, what I want you to do is think about it. Okay, what do you notice about those planets? I want you to keep that in your mind for when we look at the next model. Now we're going to skip all the way to the 16th century. We've got Nicholas Copernicus. Okay, now he was a Polish astronomer and he started creating his own model because he believed it to be different. And he actually proposed what we call a heliocentric model. Now Helios is the Greek god of the sun. So we have a heliocentric model. We have a sun-centered model. So what do you think that means? What makes it different from the geocentric and the heliocentric? What changes with the middle of our solar system? Okay, so that must mean that it must be the sun that's at the centre. So he said, finally, we shall place the sun himself at the centre of the universe. So the heliocentric model places the sun in the very centre with the other planets orbiting it, rather than Earth being orbited by the other planets. So the sun became the centre focus of his model. Now, he was still only aware of planets that you can see with your own eyes. So this is taking away other planets that you would need a very powerful telescope to be able to see, or the modern technology we have today, which is satellites and everything else that goes with it. But he did, however, make a more accurate model to suggest how far away those planets were. Now, unfortunately, because we're not at school, I cannot physically show you this, because what we would have done is gone out onto the playground and we would have measured a unit of measurement and done a scale where maybe 1 metre was 1,000 light years away. We'd be able to show you the difference and the sizes of these planets. But he did this in order to show the distance and the order that the planets would then orbit, so move around the sun. So this is his model. Okay, so have a think about this model. What looks different to this model than the last one? Okay, well, let's have a look then. So Copernicus theorised that the Earth had 3 motions, and this is what we've been looking at. We know one, the Earth moves on a daily rotation. We have 24 hours. We have half of it in day and half of it in night. When we have our seasons, obviously those days and nights are longer or shorter, but one way or another, we do a full 24-hour rotation, so a daily rotation. But we know that we also rotate around the moon. Rotate around the sun. And that takes us all year. And that's when we have our 4 different seasons. So we've got an annual revolution where we move round. But then we also have an annual tilting of the axis, because we know that we sit at always a 22-degree axis, okay? So he's claimed that the distance between the sun and the Earth is much smaller than that distance between the sun and other stars, which means this Earth must be a lot closer to the sun than some of the other planets. So what I want you to do now, just based on that information that you know, okay, if you want, you can go back and rewatch the video because I know that was a lot of information. And what I want you to do is I want you to match the fact cards and the models with the right theory. Now remember, we know that geo, like geography, study of the Earth, and centric being the centre, we have geocentric, which means it's the Earth. Therefore, Helio, which is the Greek god of the sun, and the sun in the centre, that must be the Helio one. Now, I've helped you with that one. I'm not going to help you with the rest of it now. So what I want you to do is I want you to pause the video, and I'd like to have a go at matching the correct facts and information with your 2 models. Okay? Once you've done that, come back and we'll do a short plenary. Okay. So, since Copernicus had his theory, obviously we've invented the telescope, and obviously we've had much more advancement for space travel, which has allowed us to explore our solar system in more detail. Now obviously we didn't have Uranus and Neptune at that point in time, because we couldn't see that with our own eyes from Earth. We've only worked out that those 2 planets are part of our solar system and the centre of gravity, because we've had the advancements in technology to be able to see it, okay? So this is the new model that then adds with those 2 planets here. So we've got Uranus and Neptune, which is the furthest one away, okay? Now have a think about this. How is it the same and how is it different to both the models that we've studied? Well, if we look at it, we can see we still have the orders of the planets, but we have more outside of our solar system. So we have very powerful telescopes that can actually allow us to see beyond our own solar system. And we know that we are within something called a galaxy called the Milky Way. Now, I don't mean galaxy Milky Way, the chocolate bar, okay? I mean that we're in a galaxy with a huge collection of solar systems, and it's called the Milky Way. And it is believed to contain 100 to 400 billion stars and more than 100 billion planets. Now, you think of how big we think Earth is, and now you compare that to what we have as a Milky Way, that has potentially 999,999 million planets bigger than us. Okay, that is a lot of planets for one part of our solar system. So scientists are currently exploring the surface of Mars. Okay, now that we've got the technology, we've got the Mars rovers, which are almost space buggies that they've allowed to get onto Mars, which are going to explore to see if there could have been life on what we call the red planet, the fire planet. So they're actually investigating ways to send the first humans to Mars for further investigations. So you can see how far technology has expanded to being able to explore our own planets, which quite frankly, I think is the most fascinating thing in the world. So you've come to the end of your lesson now. If that has blown your minds a little bit, go back and rewatch parts of the video. But we're going to do our very last space lesson next week before half term. Once we've done that, we're going to start a new topic, okay? So I hope you've enjoyed that lesson so far. By all means, go off and do more research if you want to. Have a nosy at the stars. See if you can look at what the moon is at night time. And we'll then come back and do our final lesson next week. All right, good luck, year 5.